So yes, now yes, we were talking about fill area primitives, right? So fill area primitives, basically, right, what I explained, what we will be trying to do here is, right, I will be having object, right? So I need to fill the area, okay, right? So that is my intention here, right? So whenever I need to fill the area, right, so the three things what I explained you, right? So for example, if I give you any object, right, and ask you to fill that with a particular color, right? First thing is, right, you will first locate the borders of that image, right? So first borders, you will check it out, right? After once you check it out the borders, right, so then only to the inside pixels of the borders, right, what you have located, for that you will go on filling the colors, right? And when you fill the colors also, you will be having the specific pattern how you fill the colors, right? So whether horizontally or whether it is vertically, fine, some pattern you will use to fill the colors, right? So now that is what first I need to do, okay, right? First I need to identify the borders, right? So next I need to identify inside pixel and outside pixel of that border, and I will take that inside pixel and I will color the particular image, okay, particular object, right? So now, uh, what is a polygon? Okay, right? So now, how they define a polygon is, right? See, this is an important definition. They will ask you in the exam, define polygon, right? And explain different types of polygon, right? A polygon is a plane figure specified by a set of three or more coordinate points, coordinate positions, right? So whenever I need to say any object as a polygon, right? So minimum we should have three vertices, right? So that particular object we call it as a polygon, right? So in the sense, right, if I have only one point, right, so this is not a polygon, right? This is just a vertex, okay, right? So now if I have any image with two points, right? So 2 points, with the 2 points, which image I can draw? I can draw a line, okay, right? So whenever I have a line, that is also not called as polygon, right? So minimum three I should have, okay, minimum three vertex I should have, right? So the object which is formed by those three, minimum three points or vertex, is called as a polygon, right? So that means the first polygon is triangle, minimum three, okay, right? So the next one may be square, okay, four, okay, right? So next, five points pentagon, right? So 6 points octagon, right? Hexagon, everything, right? It goes on like this. So minimum 3 points, right? So keep this in mind, fine. If there is a what is it, MCQ question test again for your second interest, this is a sure shot question, right? So for a particular object to be called as a polygon, right, so it should have minimum, right? So two vertices, three vertices, four vertices, eight vertices I will give you. Fine, right? So for anything to be called as a polygon, I should have minimum three vertices. The object that is formed by minimum three vertices is called as a polygon. Fine. So now, yes, before I call something as a polygon, right? So I have a terminology called as polyline. Right? Right? So what is a polyline? Right? See, a polyline is a line, okay, right, or lines, right? So which has at least one vertex in common, okay, right? What is a polyline, right? A polyline. I will tell you the difference between polyline and polygon now, okay, right? So polyline means, right, a line which has at least one vertex common, okay, that we call it as a polyline. Fine, right? So now whenever I don't have any complete object, right, so that all the edges of that are called as polyline, right? See here, I have only half of the object, right? So next half, how it should fill, it should go like this, it should come like this, right, and it should go like this, right? So this three part is not present, correct, huh? Right? So these three parts are not present. It is a open object now, correct, huh? Right? So it is a open object now. So now any open object, right? So we will call that as polyline. Okay, right? Any open object, right? We call that as polyline. That means incomplete object, right? We will call that as polyline, polylines, right? For example, if I take triangle, okay. See, this is a very important question from the point of gate, right? What is polyline? What is polygon, right? So if I take a triangle, right? So this open-ended object, I don't have closed-ended object, right? See, this particular side is still missing, right? So then I call, right, these two as polyline. Okay, right? So here also, right, this is a closed object, what we have, right? So now this is a open object. Okay, still it is not a cover, it is not covered. Hence, this is called as polylines. Fine. So now whenever the object gets covered, fine. So such objects which has more than three vertex, I call such object as polygon. Right? Fine. So polylines. So these two are polylines where a particular vertex has been shared by two lines. Right? That means if there is at least a single one common vertex between the two lines, then I call such lines as polyline. Right? So now this becomes a closed polyline, which we call it as polygon. Right? So now this is the fill area which I need to fill. Okay, right? That is the hardcore intention of this part, right? So where after after this class, in the next class, right? Finally, we will come to this part. How we will fill this polygon. Okay, right? So now this is about polygon, right? And coming to filling, right? So first type of filling, this is hollow filling. Nothing is there, only line border lines, right? So now this is solid filling, okay, where one complete color is been completely filled, right? So now this is a pattern filling, where there is some pattern here. Okay, fine. So yes, this is about polygons, right? Now whenever I come to polygon, right, I have two types of polygon. First type of polygon is convex polygon. Next type of polygon is concave polygon. Fine. So this is also a very important question for your MCQs, right? Or very prominent question from the part of MCQs, right? Now, what is a convex polygon, right? Now, convex polygon is a polygon wherein, right, there are three properties for everything. Okay, convex polygon, concave polygon. There are three properties on which we say a particular polygon is a convex polygon or a concave polygon. Remember, three properties, right? So now first property is, right, I talk about angle between each side. Okay, right? So this is one side, this is another side. Okay, na, right? So now angle between the sides, right, will always be less than 180 degree. Okay, less than 180 degree in convex polygon, right? See, the polygon is convex. The polygon is convex if all the interior angles of a polygon are less than or equal to 180 degree. Then I call such polygon as convex polygon. Okay, the first and the most important property of a polygon is this, right? The interior, all the interior angles. See whether you can see any interior angle. Okay, right? So you can see this interior angle, you can see this interior angle, you can see this interior angle, you can check out this interior angle, you can check out this interior angle, you can check out this interior angle, or you can check out this interior angle, right? All the interior angles is less than or equal to 180 degree. Okay, that is the first property of convex polygon, right? So next property is, right, if you take any 2 points, okay, right, inside the convex polygon, right, so the line joining joining the two lines will also be inside that polygon only. Okay, right? Yeah, this will be there in all the things and then next I will show concave polygon where this violates. This gets violated, right? So to see, right, this point is very silly, right? But we will see how this point gets violated in concave polygon, right? So that means whenever I have two vertex selected inside the polygon, right? So the line joining those two vertex will also be inside the polygon itself. Okay, that is the second property of convex polygon. Fine, right? So now what is the third property of convex polygon is, see here, right? Whenever I extend any side of the polygon, right? So for example, I am considering this particular side where I will extend this side further. Fine. Whenever I extend, right, any side of the polygon, right? So I should find that all other vertices of the polygon should be on one side of the one side, right? And then nodi, right, this side I have, which I have extended, right? So once I have extended this side, I can find that all other vertex, right, are towards one end of the extended line. Alva, right? This vertex, this, all the vertex are towards this one end. It may be this side or this side, right? It should be towards one end of the one end from the extended line, right? So now the same thing, let us extend this way. Okay, even though I extend this way, right, I can find that all the points, right, all the vertex are towards one side, this side, right? It is not that such that some points are in this side, some points are this side. All the points are towards one side. The same thing with respect to this. If I extend this line, right, so here also I can clearly see that all the points of my polygon are towards one side from the line which I have extended, right? And the same I can say with respect to this line, right? Even though if I extend, I can say that, right, all the points of my polygon are towards one side of the polygon. This is the third property of convex polygon, right? So first property of convex polygon, right, the angle should be less than 180 degree, less than or equal to 180 degree, right? So now second property of the polygon, if I take any two points inside interior to the polygon, the line joining those two points should also be inside the polygon, right? Third property of the polygon, right, if I extend any one side of the polygon, right, I should find that all the vertices of the polygon are towards any one side of the extended line. Okay, these three are the properties of convex polygon. Fine. Now whenever I have a convex polygon, it is very easy for me to what is that fill the polygon, right? Because if I take any two points, right, so the line joining that point is also inside the polygon, so complete line I can draw with that color, no problem, right? So but there exist some polygons, right, which we call that as concave polygon. Okay, fine, right? So where in concave polygon we find at least one interior angle of a polygon is greater than or equal to 180 degree, right? So now, okay, see this angle, okay, this angle is correct, no problem. Okay, see this angle, okay, this angle is also less than 180 degree, okay, no problem, right? So now see this angle, okay, this angle is also less than 180 degree, no problem. See this angle, okay, this angle is also less than 180 degree, no problem. But see this angle between these two edges, right? So this angle is greater than 180 degree, right? So I can so we call these as concave polygons. Okay, right? So the first property differs, right? Where the angle between the two edges, any one angle, not all the angles, right? So any one angle. See this also may be a MCQ question, right? In concave polygon, all the angles there is the angle between all the edges, all the two edges of polygon should be greater than or equal to 180 degree, right? Second option, any one of the angle between the two edges may be 180 degree, should be 180 degree, right? So third option, none of this. Fourth option, all the above two options, right? This way we may ask, right? In concave polygon, at least one edge should be, the angle of one edge should be greater than 180 degree. Then such type of polygons we call it as concave polygons. Right? Now coming to the second property, right? If I take 2 points, okay, if I take 2 points inside the polygon, okay, if point inside the polygon, right? Now when I draw a line between those 2 points, I find a part of the line is outside the polygon. See here, this is the difficulty with my concave polygon, right? Whenever I need to fill this concave polygon, right, if I take any 2 points, right, and if I start drawing the if I start filling the color, there is color pixels, right? So now there is a possibility that some part may go outside the polygon, right? So this is the disadvantage of my concave polygon, right? Whenever I have convex polygon, there is no issues, right? So whenever I take 2 points within inside the polygon, the line joining those 2 points is also inside the polygon. So whenever I take 2 points, I can easily draw the pixels between the 2 points with the required color, because I am damn sure that, right? So the line joining those 2 points will also be inside the polygon only, right? But if it is a concave polygon, then this part will be outside the polygon, right? So I cannot blindly fill the line between those 2 points with the required colors, right? So this is the second property of my polygon. Okay, right? So now what is the third property, right? So the third property says that, right, for any edge, if I extend this edge, I'm extending this edge. Okay, when I extend this edge, right? Okay, I can see all the vertex. This is one vertex. This is one vertex. This is one vertex. This is one vertex. See, all the vertex are towards one side of the polygon. Good, right? Okay, I will extend this edge, right? When I extend this edge also, I can find all the vertex towards one side of the extended edge. Okay, good, not an issue, right? So now I will extend this lower edge. Okay, when I extend this lower edge, right, here also I can find that, okay, all other points are towards towards one side of the extended edge. Okay, fine. Now I will extend this edge. Okay, now if I extend this edge, what is happening? Okay, right, see, first vertex, second vertex, third vertex are towards one side of the extended edge. This is my extended edge. Towards one side of the extended edge, I have first vertex, second vertex, and third vertex. See this fourth vertex. This fourth vertex is towards the other side of the extended edge. This was my extended edge. My first, second, and third point was towards this side. Okay, right? So towards this side of my extended edge, right? And my fourth vertex is towards the other side of my extended edge, right? So which, whenever this things happens, right, we call such type of polygons as concave polygons. Okay, fine. So three properties again. So the angle between any two edges, if a polygon, if any one of the angle crosses 180 degree, then that is a concave polygon. If I take any two vertex inside the polygon, and if I draw a line between those 2 points, right, so a part of the line will be outside the polygon, right? So that is the next property of concave polygon. The third property, whenever I take an edge and whenever I extend the edge, right, I find that some part of the vertices is present on one side of the other edge, and some part of the vertices is present on other side of the vertex. Sorry, other side of the extended edge, right? So this also violates the convex polygon rules, and this becomes concave polygon, right? So now what is the problems with my concave polygon? The problem with my concave polygon is implementation of fill algorithms and other graphic routines are more complicated. Why it becomes complicated? Because of this property. If I take any two vertex and I cannot blindly go on filling the line between the two vertex with the required color, thinking that complete line will be inside the polygon, because some part of the line will be outside the polygon, which is where that particular color filling should not be done. Right? That is the problem with the concave polygon. This may be another MCQ question. The problem with the concave polygon is, I will give any three along with that. This implementation of fill algorithms will be difficult. So what is the solution that we do, right? For convex, right, there is no problem. If I take any two vertex, right, inside the polygon, and if I draw the edge or if I draw the line, so that complete line will be inside the polygon only, and there is no problem. I can fill the colors. Okay, that means that complete edge I can fill with required color. Go on filling, right? So, but in my concave polygon, as I cannot do that, so what is the solution is, right? So, what the solution is? I should get convex polygon to fill the color clearly. Alva, right? So, what I will do, I will split the concave polygons into set of convex polygons before processing. Okay, that means before I start filling the color, right, inside my polygon, if that particular polygon is a concave polygon, right, I will fill that concave polygon with the, what's this? Oh, sorry, I will break that concave polygon into convex polygons, right? And finally, for to fill the color, right, so my polygon should be convex polygon. Okay, right? So now, okay, I see I'm just we have eyes and I'm seeing the diagram, right? And I can make out the angles, right? Because I have been trained, okay, right? I have been trained from my middle class, right? So that how to find the angle between the two edges and which angle is less than 180 degree, which angle is greater than 180 degree. I have been trained, right? So as soon as I see the polygon, I will understand which polygon is convex polygon, which polygon is concave polygon, right? But how to make my computer understand that which polygon is convex polygon, which polygon is concave polygon? That's a challenging task, right? So to make my polygon understand, hmm, to make my polygon understand, right? So which polygon is convex polygon, which polygon is concave polygon? That means, right? So in my given diagram, right, is there any edge which is making greater than 180 degree angle? To make out for my computer, right, I need some other techniques and tactics to do that. First, I need to identify whether a polygon is concave or convex. So that next I can divide the concave polygon into convex polygon. That is the next part, how I will divide. First thing is I need to identify whether a polygon is concave polygon or a convex polygon. Okay, right? So how do we do that? Fine, right? So identification algorithm. This is the first identification algorithm. Identification algorithm 1. Okay, right? So I will go with this afterwards, right? First, I will check it out. Fine, right? So first thing is I will check it out with the second algorithm, which is simple. Fine, right? So second algorithm says that look at the polygon vertex position relative to the extension of the line of any edge. If some vertex are on other side of the extension and some vertex are, if some vertex that is right, if some vertex are one side of the extension and some vertex are on the other side, then the concave, then the polygon is concave. I will use this property, right? So where I will extend the edge. Okay, right? So when I extend the edge, right, I can clearly make it out that V1, V2, V3, V6 are on one side of the polygon and V5 is on other side of the polygon. Okay, when I extend this edge V3, V4. Fine. So then I will come to a conclusion that, okay, yes, I have my polygon which is there is a concave polygon. Fine, right? So now, fine, right? So let us come to the first method, right? Identification algorithm 1. Okay, right? So what identification algorithm 1 says is we can identify whether a polygon is concave polygon by calculating the cross product between the successive pair of edge vectors. Okay, right? So we can come to know whether my polygon is concave or convex by calculating the cross products of successive pairs of edge vectors. Okay, right? So now how to, what is this concept, I will let you know, right? So now whenever we calculate the cross product of the successive pairs of edge vectors, right, and whenever we see that the cross product of any of the successive pair of edges is less than 0, then I will come to a conclusion that, okay, right, my polygon which is there is a concave polygon. Okay, right? So let me see here, right? So cross product between the two edges. That is what they are telling, right? I need to find the cross product between the two edges. Fine. So this is my first edge. This is my second edge. Okay, E1, E2. I am finding the cross product of E1, E2. Right? And that cross product is greater than 0. Fine. Now let us just check it out. How to find the cross product between the two edges. Okay, right? So now I want everyone to observe the things. Fine, right? Now I will explain you how to find the cross product of each edges. Fine. So I want everyone to observe. If anybody has any confusion, just interrupt me there itself and clear the things, because this finding the cross product is required in the next part. Okay, right? So now consider this is my first edge and this is my second edge. Fine, right? Now how to find the cross product between edge 1 and edge 2? Fine. See, all these things, see, they nowhere in the book or anywhere you can find how to find the cross product or anything, right? See, I have referred many YouTube channels, many mathematical YouTube channels, and I have come up with the things. Fine. So I want the same interest from you people to be shown. Okay, right? So now, first thing is, right? See, yes, this is the same diagram. Same diagram. Huh? Okay, let it be a different diagram. Let us take this diagram which is there. Okay, right? So now let us take this particular diagram. Fine. So this is the same diagram which is there, right? What I need to find? I need to find cross product between edge 1 and edge 2. Okay, right? So now edge 1 in the sense, 1 minute. Okay, right? So now what I want is, right, I want the cross product between edge 1 and edge 2. Okay, now, right, cross product x and we will mention, which I am representing by this asterisk mark. Okay, right, cross product between E1 and E2, right, is nothing but, right, so the vertex value of that is okay, fine, right? So it is nothing but, right, so E2 minus E1. Okay, right? So cross product of E1 and E2, edge E1 and E2, it is nothing but, right, so edge 2 minus edge 1. Okay, right, edge 2 minus edge 1, right? So now let us find what is E1 and what is E2. Okay, right? So first I will let you know what is E1. E1. Okay. I'll increase the font. Right? So first let me know. See, cross product of E1 and E2 is nothing but they say E2 minus E1. Right? So now what is this E1? What is this E2 is my next next question, right? So now what is my E1 is, right? So E1 edge, right? The value of this E1 edge is the value of vertex V2 minus value of vertex V1. Okay, value of my vertex V2 minus value of my vertex V1, right? So now what is V1 V2, right? So now V2, right? So see, these are the coordinates, right? X is 0, x is 1, x is 2, y is 0, y is 1, y is 2, right? So now what is the coordinates of V2? That is for my vertex V2, what is the position of x, y and z? X, y, what is the value of x, y coordinates for my V2? This is my V2 vertex, right? Now, what is the x coordinate value and what is the y coordinate value of this V2? Henry, what is the x coordinate value and y coordinate value of V2? V2 do what is the value of x coordinate and what is the value of y coordinate? X coordinate is 1, y coordinate is 0, right? So what is the value of my V2? It is 1 towards x, right? And 0 towards y, right? And z also I will take it as 0 because z is not there, it is 2D, right? I will take it as 0 only, right? So this is my V2, right? Minus what is the value of my V1? What is the value of my V1? V1 means this, right? V1 means this. That means x is also 0, y is also 0. That means 0, comma 0, comma 0. That is 0, I will take it, right? So V2 minus V1, right? It is this way. Okay, right? So my V1 is 100, that is 10. Okay, right? X1, Y0, right? And my V1 it is 0, comma 0, comma 0. That means, right? So X and Y both are 0, that I will take it as 0 only, right? So now V2 minus V1 is nothing but, right? So respective axis difference. Okay, V2 minus V1 alva, right? So now X axis of when I can get, right? So x-axis of V2 minus y-axis, x-axis of V1. Okay, x-axis of V2 is 1. Okay, x-axis of V1 is 0. So V2 minus V1 for x, it becomes 1. On the same lines, right? So y-axis of V2 is 0, y-axis of V1 is 0. That means, right? So in V2 minus V1, y-axis is 0 and z-axis it is obviously 0, right? So now, so E1, right, is nothing but it is V2 minus V1, which is E1 will be 1 comma 0 comma 0. This is my edge one. Okay, right? This is how I got my edge one, right? So edge one, it is nothing but, right, which edge, which what is are making edge one? It is V1 and V2, right? So it is E1 is nothing but V2 minus V1. So what is V2? V2 is x, y, and z coordinate values, right? So V2's x coordinate is 1, y coordinate is 0. That is 1 0. That coordinate I will make it as 0 only, right? Minus V1. What is the coordinate values of V1? It is 0 along x, 0 along y. So 0 0 0. Fine. Fine, right? So now then V2 minus V1 means, right, respective axis differences, right? So x axis of V2 minus x axis of V1, 1 minus 0, it is 1, right? So now y axis of V2 minus y axis of V1, right? So 0 minus 0, it is 0, right? And that is with respect to z also, it is same thing, right? So E1 is 1 comma 0 comma 0. On the same lines, I will also find E2. Okay, right? So E2 andre it is V2 and V3. Fine, right? So now V3 minus V2 I will take, right? So the same thing I will go on taking the values, right? So next I got V1 and V, that is this is E1 E2. Fine, right? So E1 is V2 minus V1, right? E2 is, on the same lines I will go on finding, right? So next, how I will be finding the cross product is, yes, see here, right? So cross product between the two edges is, my first edge is 110, my second edge E1, if I take, right, E1 edge as that is 110, and if I take E2 edge is also 110. Fine, right? So how do I take the cross product between these two edges is, right? So for the cross product of my first row, for the cross product of my first row, what I will be doing is, right, I will be multiplying the second rows, second and third rows. Okay, right? So what I will do is I will multiply, right, first column of the second row with the second column of the third row. 1 into 0. Just 1 minute, I will come back. Okay, fine. So how will you find E1 into E2 is, right? So if my first vertex is 110, first edge, and second edge is 110, this is also right. So now how do I get the first row is, that is the x-axis is, right? So it is multiplying the second row and third row elements of, right. How I will multiply second and third row elements, right? I will take the first column of second row and I will multiply with the second column of, I will multiply with the second column of third row. Okay, 1 into 0. 1 into 0. Right? So minus, fine, this one. Okay, second row, second column into third row, first column. Right? 1 into 1 into 0 minus 0 into 1. It is 0. Okay, right. So now coming to the, for the how I will be getting this particular thing is, right, that is my second my, my second value is, right. So this row, that means the second row I will nullify, right. I will multiply first row with the third row, that is 1 into 0 minus 0 into 1, right. 1 into 0 minus 1 into 0 or 0 into 1, anything, it again becomes 0. Okay, right. So now come to the third column, right? How I will do with respect to the third row is, that is with this z component is, right. So I will eliminate this third one. I will eliminate the third row. I will eliminate the third row means, right, for the third row value, right, I will use first row and second rows cross product. Okay, 1 into 1 minus 1 into 1. 1 into 1 is 1 minus 1. So the value is not 1, it is equal to 0. Right? And for checking whether the cross product between the two, right, is greater than 0 or it is less than 0, I need to check the z component. This is a z component. This is first component is x component, next component is y component, third component is z component. Right? I will check the z component value. Okay, if the z component value is greater than 0, right? So I say if the z component value is greater than 0, then I say the cross product between the two edges is positive, is greater than 0. If this z component is less than 0, then I say, right, the cross product between the two edges is less than 0. Okay, right? So finding the cross product between the edges, first I need to find each edge, right? How do I find each edge, right? It is nothing but the difference between the vertices. Okay, right? How do I find the difference between the vertices? It is nothing but the difference between the coordinates of those vertices with respective axis. That means I will take the value of each vertex. Okay, value of each vertex means the coordinate positions of each vertex. So V2, where is V2? It is x-axis, 1 unit by x-axis, 0 unit by y-axis. Right, so I have taken 1 0. For z-axis, I will take it as 0. On the same lines for this also, right, for y1, so 0 0 0. And when I take the difference of this v2 minus v1 with respect to the axis, right, so x-axis of v2 minus x-axis of v1, y-axis of v2 minus y-axis of v1, z-axis of v2 minus z-axis of v1. If I take that, right, I will get the value of my edge. Right, like this for each edge I need to take, right. So and I need to go on checking the cross product between the all the edges, right? How do I calculate the cross product? It is this way, right? I take my first edge, I take my second edge, right? So for getting the x coordinate value of the cross product, right? So I will eliminate this first row, right? And I will take the cross product of second and third row. Cross product andre 1 into 0, right? Minus 0, 1 into 0 or 0 into 1, right? So for the second this one, right? That is for y axis value of the cross product, right? I will neglect the second row and I will take first row and third row cross product, that is 1 into 0 minus 1 into 0. Fine. So for the z axis of my cross product, right, I will take the first row and second row cross product, right? 1 into 1 minus 1 into 1, that is 0 minus 0, it again becomes 0. And to come to a conclusion whether the cross product is greater than 0 or less than 0, I will check the z component. Okay, I will check the z component of my cross product value. If the z component of my cross product value is greater than 0, then I say the cross product of the between those two edges is greater than 0. If the z component is less than 0, then I say the cross product between the two edges is less than 0, right? So now that is what I have performed for each of these edges. Okay, first I have taken E1 into E2 cross product, that is E1 into E2, right? So next I have taken E2 into E3, next I have taken E3 into E4. Whenever I go on calculating this cross product, I came to know that E3 and E4 cross product, andre E edge, E edge, right? So these two edges cross product, fine, these two edges cross product turned out to be less than 0. Okay, right? When the cross product between these two edges turned out to be less than 0, then I came to conclusion that yes, at least one of the cross product is less than 0. So my given image or that is given figure is concave polygon. It is not convex polygon, right? This is the first algorithm. First algorithm says that I will take the cross product between all the successive edges, right? If any of the cross product turns out to be negative, then I say my given polygon is concave polygon, right? My second algorithm says that how I find whether given algorithm is concave or concave algorithm is, right? So I will go on extending the edges and I will be checking the vertices. If all the vertices are towards one side of the extended edge, then I will say that is a convex polygon, right? So when I go on doing this thing, right, when I extend this E3 edge, right, I find that V2, V3, V6 is on one side and V5 is on another side of the extended edge. So I come to a conclusion that okay, this is a concave polygon. Okay. Now once I get the concave polygon, right, so next thing is I need to split the concave polygons into convex polygons. Okay, that is what the thing, right? Concave polygons I cannot draw. That was the difficulty with my concave polygon. Fill algorithms, it is difficulty because some part I will get it as outside the polygon. So what I need to do, right? So I need to separate that, or I need to break that into convex polygons, right? So to break that into convex polygon, a given image, first I need to check whether that is concave polygon or not. How I will check whether it is concave polygon or not? These two are the algorithms. Okay, right? So first algorithm, vector the cross product method. Second is, right, extending the edge method. Okay. So yes, this is where we will stop. Okay, not stop the recording. Fine. So this is where I will stop my presentation. Fine. So in the next class, we will be checking, right? We identified concave polygons. Next, how do we split that concave polygons into two different convex polygons? Okay, right? So that is the next thing that we will be seeing in the next class. So now, Shilpa, Shilpa, Sibin, Sibin.
Yes, sir.
Will you present Sibin or first Shilpa
Okay,
will
sir.
do? Present, present. Explain. See, these things are the basic concepts which you require wherever you go, right? Being a computer science engineer, it is a must to have a basic knowledge about mathematics. You cannot run out of mathematics. Fine. So on this, right, in our road, whenever we talked about rotation, right? So we clearly came to know that about sin x and cos x. Sin of minus theta, we said it is minus sin theta, but cos of minus theta, we said that is cos theta. It is not minus cos theta, right? So that thing, see, all these things you have read in your high school mathematics, right? Only it is a revision of the thing, fine. So which you people will also have a experience of presenting and doing the seminar, fine. That is the whole and sole reason why I am doing the things.
Sir, is my voice audible?
Audible, audible.
Sir, is screen visible?
It is visible, visible.
Good morning, friends. Today I am going to give a very small seminar on to prove sine of minus theta is equal to minus sine theta and cos of minus theta is equal to cos theta using waveform or using graph. As sir told, it is these topics we are studied in our high schools and also in our previous semester, so we can just revise this. Before that, we know about there are two types of function: even function and odd function. So let us look into even function. In even function, we know when we put a negative value for input x, even then we get the same value for output f of x. That is, whenever we are going to give input as -1 or -2 the function, we are going to get the output as the same as the input, and the output sign is never going to change. It is going to remain as f of x only. So we can say that type of function is known as symmetric to y-axis. Let us look into odd functions. Here you can see that given a negative input for x, the output is the negative value for output f of x. Whenever we are going to give a negative input for a function, we are going to get the negative of output, that is minus of f of x. This graph, such a graph is known as symmetric to the origin. Whenever you're going to look at a graph of cosine or a graph or a waveform of cosine, seeing the eye point of the graph crosses the y-axis, and that's the cosine curve. And whenever if, for example, we are going to take pi by 2 and minus pi by 2, then we can understand that they are the same distance but in the opposite direction, and the cosine is cosine of x, also cosine of minus x, is both cases we get the same value for y. That is, graph of cos x is symmetric about the y-axis. You get the same values as output for every pair of positive and negative input x. As we have seen here, instead of x, I write pi by 2 and minus pi by 2. For positive and negative pi by 2 and minus pi by 2, we are going to get the same pair of values. Then such a function is known as cosine function, and cosine function is the even function. As we looked before, the even function, we know that whenever we are going to give the output, input, negative input, we are going to get the positive output, and f of x is never going to be altered. Let us take an example, like let x is equal to 180 by 4, that is pi by 4. F of x, cos of pi by 4 is equal to 0.707, and cos of minus 1 pi by 4 also is equal to 0.707. So f of the output f of x is not altered. We can also notice that pi by 4 lies in the fourth quadrant. Hence, all cos values are positive in the fourth quadrant. let us look into the graph of sine or the waveform of sine. We can see that we can identify the waveform like a curve passes through the origin, and the values to the right of the y-axis need to be positive, and the values to the left side should need to be negative. When let's take the point as pi by 2 and minus pi by 2 on the left side. Here we can see that the distance is same, just one time in the positive direction and one time in the negative direction. We take now the value of sine of pi by 2, and we see that we get in this case the I point of the curve at +1 on y-axis. And when we are considering the value of minus pi by 2, we get the low point of the curve at -1 and but the magnitude of pi by 2 and minus pi by 2 is same as distance, but one time it's a positive number. That is, graph of sin x is symmetric about the origin, but the graph of cosine is symmetric. Graph of cosine, we can understand it is symmetric about y-axis, and graph of sin x symmetric about the origin. Here we can check that x is equal to 180 by 4, that is pi by 4. F of x of sine of pi by 4 is equal to 0.707. F of minus x is equal to sine of minus 180 by 4, or sine of minus pi by 4 is equal to minus 0.7. That is nothing but, if f of x is 0.707 but f of minus x is minus 0.707, we can conclude that the output is minus f of x. It is the odd function. Here it ends. This is how we are going to see in waveform or in graph method that that what we are about to find was.
Okay, yes, good, Sivan. It was very clear. Okay, and very good attempt, Sivan.
Thank you.
Okay, can you stop presenting? Fine, right? So that means what? 1 minute, right? Yes. Okay. What he told was. Okay, right. So now what he concluded was, see, uh, right now this is my sine function. Okay, this is my sine function, and this is my cos function. Fine, right? So now whenever we see the waveform, how it looks is your sine function waveform looks like this. Okay, your cos function waveform looks like this. Okay, right? So that means, so this is minus, this is plus. First quadrant, second quadrant, right? So first quadrant, second, that is second quadrant, right? X will plus irutta, this is plus x, so this x will be minus here, right? So this is x will be plus here, x will be minus here. See, now when you come to cos theta, right, what happens whenever I have minus x value, that is minus theta also, right? So my value is positive only, and whenever I have plus theta also, the value is positive only, right? So that is why cos of minus theta, right, is also equal to cos theta, where cos of minus theta waveform is this, cos of plus theta waveform is this. Both are on the positive side only. Fine. right? So that is why cos of minus theta becomes cos theta, fine. But when I come to sine form, right, I can clearly see this, right? So whenever my theta value goes on comes to negative side, that means whenever it comes to negative side, I can see what is the magnitude. Okay, magnitude becomes negative. Okay, right? So ಇಲ್ಲಿಂದ ಈಗ when I go across this, right, the x value is minus ಅಂದ್ರೆ minus theta ಹೋಗ್ತಾ ಇದೆ. Whenever it goes beyond minus theta, right, so then the value gets decreased ಅಂದ್ರೆ value becomes negative, right? Whenever it comes to positive side, my theta, the value is positive, right? That means the magnitude is same, only the sign is difference, right? Hence the sign of minus theta is minus sin theta, right? Here cos of minus theta is also plus cos theta because this is the waveform. Okay, fine. This is how by waveform method they explain you cos theta and sin theta. Okay, right? So
So
yes,
shall I?
yes. I will stop it. Hmm.
Screen is visible.
Visible, Shita.
Yes, good morning to all. Today, I am going to prove why cos minus theta is equal to cos theta and
ಶಿಲ್ಪ
sin minus.
ಲೇಸರ್ ಇದೆ ನೋಡಿ, ತಗೊಳ್ಳಿ. ಲಾಸ್ಟ್ ಲೇಸರ್ ಇದೆ ನೋಡಿ, ಸೊ ದಟ್ ಎಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ.
First, let's take the proof. Why cos minus theta is equal to cos theta and sin minus theta is equal to minus sin theta. First, we consider the xy plane. In that xy coordinates, in middle points, let's take as origin. Origin is marked as point 0 O, and if we draw a line in the plane that is in anti-clockwise direction, we get one radius that is marked as A and that is considered as OA is marked as radius R. In the radius R and the x-axis, it makes an angle that is theta, which is positive theta. I did not write theta here. And again, if we move from downwards in clockwise direction, we get another one radius that is OB. That is also considered where angle between the x-axis and this radius. Again, it makes the theta which is negative theta. This is positive theta. This is negative theta. After that, if we draw a parallel line to the y-axis where it makes an one triangle, that is right angle triangle, which is a 90 degree, which makes a 90 degree, where from where in this triangle all the sides will be equal by knowing that OA will be equal to OB. Again, let's take OM as the x and AM be the positive y and MB be the negative y. By drawing all this, now we'll start the proof of cos minus theta is equal to cos theta. First, we will take the cos minus theta is equal to cos theta, where cos positive theta, which is equal to cos theta means adjacent by hypotenuse, where that is equal to OM divided by OA, which is equal to x by r. Where cos theta is equal to x by r, which is equal to positive, that is considered as equation 1 in the triangle OAM. After that, in the triangle OMB, if we take cos minus theta is equal to OM divided by OB, which is equal to x by r. that is equal to cos minus theta is equal to x by r. That is considered as equation 2. Now substituting or putting equation 1 into equation 2, we get that cos minus theta which is equal to x by r, where x by r means cos theta. So therefore cos minus theta is equal to cos theta. Hence it is proved. Next again, if we consider in the triangle OAM, if we take the sine positive theta, which is equal to sine theta means opposite by hypotenuse. Opposite by hypotenuse means AM divided by OA, which is equal to y by r. Therefore, sin cos like sine positive minus not positive theta, which is equal to y by r. Where again, if we take in triangle OMB, which is equal to sine minus theta, that is equal to MB divided by OB, which is equal to minus y by r. Therefore, this will be equation 1, this will be again equation 2. Again, substituting or putting equation 1 into equation 2, we get sin minus theta is equal to minus sin theta. Hence, by conclusion, we wind up that cos minus theta is equal to cos theta and sin minus theta is equal to minus sin theta by proved by using the trigonometric ratios. Thank you.
Neat presentation. It was the information was clear to understand the things. Correct, right? So did you understand by trigonometric way, right? She proved that cos of minus theta is cos theta and sine of minus theta is minus sine theta. Okay, right? So this is that is how she proved, right? So yes, in the next week session, right? So you will be having a short presentation on metrics and its multiplication. Okay, by Tejaswini ala. Tejaswini
Yes, sir.
okay, right? So where she will explain what is a matrix. Okay, right? So then addition of matrix and multiplication of matrix. Fine. So along with her in the next class, I want some another one, right, to explain the cross product and dot product. Okay, because this cross product and dot product concept is there, right? I want someone to explain cross product and dot product. Who will do that? Cross product and dot product concept. Hmm? Anybody come up? Very simple concept. Okay, ಇವಾಗ ಏನ್ ಮಾಡಿದ್ರು, right? That much if you do, where your friends can understand, it is more than enough, right? Instead of writing 10 to 15 pages of assignment, this is very simple. Yes, somebody who will do a small session on cross product and dot product. ಹ್ಮ್ 3D ಮಾಡ್ತೀರಾ ಎಲ್ಲರೂ ನೆಕ್ಸ್ಟ್ ಹಂಗಾರೆ? 3D Z ಕಾಂಪೊನೆಂಟ್ ಬರುತ್ತೆ, ಅದನ್ನ ನೀವು ಹೇಳೋದೇ ಕಷ್ಟ ಆಗುತ್ತೆ. ಎಸ್, who will do on cross product and dot product? ಬೇಗ ಮುಗಿಸೋಣ ಕ್ಲಾಸು. ಯಶಸ್, ಯಶಸ್, ಯಶಸ್. Okay, he replies or doesn't reply, right? So Yashas will give session on cross product and dot product. Okay, simple, 5 minutes ಸಾಕು, right? How to do dot product, how to do cross product ಅಷ್ಟೇ. ಓಕೆ, ಇವತ್ತಿಲ್ವಾ ಅಥವಾ ಇಲ್ವೇ ಇಲ್ಲಪ್ಪ ಮೈಕ್? ಯಶಸ್, ನೋ ಮೈಕ್ ಫಾರ್ ಟುಡೇ ಆರ್ ಪರ್ಮನೆಂಟ್ಲಿ? Okay, yes, it will be Yashas and Tejaswini, right? Hey, Yashaswini, 105 USN. Yashaswini, Yashaswini, 105. The Yashaswini, 105 USN. ಇದೀರಾ? ಪಿಂಗ್ ಆದ್ರೂ ಮಾಡಿ. ಓಕೆ, ಸಿ ಯಶಸ್ವಿನಿ 105 USN ಅಥವಾ ಫ್ರೆಂಡ್ಸ್ ಯಾರಾದ್ರೂ ಇದ್ರೆ ಅವರಾದ್ರೂ ಹೇಳ್ರಪ್ಪ ಅವ್ರಿಗೆ, ರೈಟ್? ಸೊ ಲಾಸ್ಟ್ ವೀಕ್ದು ಲ್ಯಾಬ್ ಸೆಷನ್ recording is with Yashaswini, right? Kindly share Yashaswini to me. Other students are asking me for the recording. Okay. Okay, Yashas, if there is any problem with Yashas, fine. So that will be taken up by who? Yes, who will take up if Yashas has some problem? Usha? Usha? Oh, bitter Usha. USN 94, Usha? USN 94, Usha? Okay, Usha, yes, 94 will do session on dot product and cross product. Okay. Okay. Tejaswini, GL 19CS 413. ಇದೀರಾ?